Okay, today I'm going to explain and give the overall idea about the what is the TOC subject. So what is the importance of the TOC subject in the gate point of view? Okay, how many marks will get the will get the will get from the TOC subject? Okay, now what is first of all before going to the our syllabus? First of all, what is mean by TOC? So what are the applications of TOC? What are the applications of uh, what are the applications of the TOC in our computer science field? Okay, that's why first of all the theory of computation. The theory of computation means what? Generally, it is belongs to the that is a branch of mathematics. But what kind of mathematics there? Computer science related mathematics. Now the theory of computation is called as. That means we are going to study some theories related to the how you are solving the problems by using of some procedures, by using of some models. Okay, such kind of theory we are going to learn from the theory of computation subject. Okay, that means generally if we take the some problem by using of some algorithm, we'll get the solution. That is okay. But here, how you are getting the efficiency output from this model? Okay, such kind of theories, such kind of algorithms. Okay, we are learning from this subject. That's why here what you have, what are the contents are there? Actually, we have the four models are there. That means four modules are there. The entire TOC subject is divided into the four modules. The first module is belongs to the first module is the first module is belongs to the that is the finite automata and regular expressions. That's why here in the chapter, here I am going to discuss about all these topics, finite automata and regular expressions. And next one is maximum 70% of the bits from the finite automata and regular expression concepts. And afterwards, the next module is belongs to the context-free grammars and PDA. Context-free grammars and PDA. The context-free grammars and PDA, and afterwards we have the pumping lemma concepts are there. Pumping lemma, and next one is called as the what is in by context free grammar, what is in by context free language, what is in by regular language. Then afterwards final notation is called as the that is the Turing machines and undecidability. Okay, these are the four modules are there, but maximum 70% of the bits from the first module, that is called as the finite automata and regular expressions. Okay, afterwards the remain 30% is context free languages and PDA. Afterwards pumping lemma concepts and undecidability and Turing machines. Okay, and now today first of all, can you give the any example for the theory of computation? Any applications for the theory of computation? Anyone? What are the applications of the theory of computations? Applications of theory of computations. Okay, here the main application is here. Suppose here we are going to design a model. That means the model means what? That may be software model or hardware model. That means if you take the some compiler is also one of the application for the TOC. And for example, lift is also another application for the TOC. Now, first of all, so what is mean by? Okay, what is mean by model here? The model means we have the different kinds of models are there. That is called as the finite automata is there. In finite automata, again we have two models are there. That is called as the DFA and NFA. That's why here all the concepts here, what are the topics we'll discuss under the finite automata and regular expressions. Okay, all the topics here presented here. That is called regular expressions and equivalence of the regular expressions, finite automata. And again in the finite automata, NFA is there, DFA is there. How to equalize the NFA and DFA. So what are the concepts of NFA? So what is the minimization of DFA and everything? Everything is there with from the some shortcut format. And again we have the find automata with output also there. Find automata with output means what that is called meal emission and more emissions. What are the equivalents of meal and more emissions? Okay, and all these topics I will explain. I will explain now. First of all, and before going to the model, suppose here I want to go I I want to construct some model. And if you want to construct any model, so first of all, what are the required concepts? That means if you want to design a model, first we need to understand what is the concept, what is the context for designing the model, on what basis we are designing the model. That means we need to understand it. So when we'll get the understanding concept, that means suppose if you want to construct some compiler, okay, okay, the compiler is constructing for what? Either C language or Java language or something. That means we need to understand the C language, na? Then only your considered compiler is it working properly or not? Is it C language is executed on the compiler or not? That's why here we need to understand the language. Here we need to understand the language of the compiler, language of the model. Then only we can understand what I constructed, that is the right or wrong. That's why the first one is here. Before going to the any model, before construction of any model, before going to any system, first of all we need to understand how to communicate with this model, how to communicate with the system. That means for communication purpose, what is the requirement? That is called language is required. That's why here we are learning about this some formal languages. So in the languages, what are the concepts are there? If you take any language, if you want to learn any language, always should start from the where? From the alphabets. That's why the main central concepts of the finite automata and TOC subject is that is called, the first one is called as the alphabet. So what is mean by alphabet? And what is mean by, and again instead of alphabet I am giving one more concept that is called symbol. So what is the difference between the alphabet and symbol? Anyone? What is the difference between the alphabet and symbol? What is mean by alphabet and what is mean by symbol? What is mean by alphabet and what is mean by symbol? Alphabet is called as a finite and non-empty set of symbols. Finite and non-empty set of symbols. But what is by symbol? Symbol can be anything. Symbol can be anything. If you take hash character, if you take the comma character, if you take the for example full stop character, everything is called as the symbol. But if it comes to the alphabet, that is alphabet is not like that. Alphabet should be, that is a finite or non-empty set of input symbols. That is a finite characters. That is not a continuous character, unlimited characters. Because of if it is a continuous characters and unlimited characters means what? We are not able to provide the syntactic rules and grammatical rules. And next one is what are the valid words in our compiler. That means if you write anything, that is the correct. But here not like that. The alpha that is called alphabet means that is only specified characters. Specified characters means what? How you are explaining specified characters are not? That means if I take the some binary language, so what are the alphabets are there? That is 0 comma 1. That means it contains the finite and non-empty set of input symbols. Finite, compulsory limited number of symbols are required. Non-empty, at least one character is required. Then only that is considered the okay alphabet. Finite or non-empty set of input symbols, and in it is denoted by the sigma. It is denoted by the sigma. That's why here if I take the some sigma equals to 0 comma 1. Okay, when we'll consider as 0 comma 1, that means if you take as a binary language, the alphabets are belongs to the 0 and 1. If I take the some English language, sigma equals to what? A to excuse me, that is A to Z. A to Z. that is A to Z. Next one is if you take a ternary language that is called as the 0, 1, 2. That means 3 characters are required. That's why based of suppose if we take the 0, sigma equal to 0, sigma equal to 1. Okay, we can take any combinations, then it is considered the alphabet. Now suppose if I consider sigma equal to 0 to 0, 1, 2, 3 up to n, is it possible? No, because of that is limited characters are required. That's why the sigma should be finite and non-empty set of input symbols. Set of input symbols. And next one is the combination of alphabets, the collection of alphabets. The collection of alphabets is considered as the string or word. The collection of alphabets is called as string or word. That's the number of symbols in the string is denoted by the W. W. That's why the string is a finite collection of symbols from the alphabet. That's why that is W belongs to the. So, for example, if you give the any characters, okay, we can write it. And next one is, for example, if what is the and one more thing is one more string is the string can be collection of symbols. The symbol should be derived from where? From the alphabet only. The string should be derived from the alphabet only. Suppose if I can, in my language 0, 1, 0, 1 is called as alphabets, but if I wrote the that is 0, 1, 2, is it valid string? No, because of 2 means that is not available in my language. That's why what are the strings are there, that means what are the symbols are available on the string, all the characters should be derived from the sigma, then only it is considered the string or word. It is denoted by the small w. It is denoted by the small w. Next one is here. So what are the operations we can perform on the string? The string is okay, but means why you want to learn all these concepts? That means here we are going to interact with the machine, you are interact with the compiler. How you are interact with the compiler? That means by using the language notations. That's why before going to the learning of the language, first what the basic characters are required? The basic characters are that is called as the what is in by alphabet, what is in by string, what is in by length of alphabet, what is the what is the number of operations on the alphabets. Okay, what are the number of strings operations on the strings, and everything if you learned it, then we can design the language, and based on the language we can design the model. Okay, the way of constructing the model is study is called as the theory of computation. Okay, now string length. The length means what? How many number of characters available on the string, that is called as the string length. And the number means what? That is represented by the mod character, mod w. That means the number of strings, number of characters available on the string, that is called as the length of the string. Suppose if I consider I have here mod w equal to mod Vardhan, that means how many characters are there here? 7 characters. And next one is empty string also there. In that string we have the one notation is there, that is called as empty string. Empty string means what? Zero length string is called as the zero length string is called as empty string. Okay, how to identify the zero length string? That is represented by the epsilon. Okay, empty string is also denoted by the epsilon, and length of empty string is called as the length of empty string is length of empty string is called as epsilon, that is called as 0. Okay, the empty string follows, that means epsilon into something is there, epsilon into w equal to w, w into epsilon is also w. Okay, and next one is remaining operations. Prefix of a string, suffix of a string. What is the prefix and what is the suffix of a string? Suppose here if the prefix means what? The leading characters of the string is called as the. Okay, the prefix means what? The leading characters of the string is called as the prefix of a string. Suffix means what? The trailing characters of the string is called as the suffix of a string. Suppose if I consider as Here W1 and W2 is there. W1 is there. W1 and W2. A, B, C and W2 is D, E, F. Now prefix of W1 is prefix of W1. What is the prefix here? Epsilon is a prefix and suffix for every string. Epsilon is prefix and suffix for the every string. Now here epsilon A, AB, ABC is called as the prefix of a string. That is called as the prefix of the string. That is, now the here all of you note down the one point here. Okay, if the string length is n, how many number of prefixes are there? How many number of prefixes are there? That is called as the n plus 1 prefixes are there. If the string length is n plus 1 prefixes are there. Okay, and next one is, what about the suffix? Suffix means what? The trailing characters of the string is called as the, that is called as the trailing characters of the string is called as the suffix of a string. That's why in the given definition, factoring or removing leading symbols. Removing leading symbols means what? That means the trailing characters. So this is called as the suffix of a string. Now the suffix equal to what? Epsilon, and epsilon is a prefix and suffix and substring for the every string. That's why epsilon C. Next one is suffix is C, and next one is BC. That is not ABC. Sorry. Here this is called as the BC. Okay, epsilon C, BC or ABC. Okay. Next one is concatenation. So what is meant by concatenation? Concatenation of two strings. Concatenation means what? Concatenation means what? That is called as the combination of two strings and string 1 followed by string 2 without having any spaces. So that is called the concatenation, and the operator name is called as the dot operator. The operator name is called as the dot operator. That's why in the third example we have the W1 followed by W2. W1 followed by W2. That is called as ABC followed by DEF. That means W1 dot W2. Okay, this notation is called as the concatenation of a string. Concatenation of the more than one string, that is called as the concatenation. The operator name is called as the dot operator. Okay, next one is palindrome of a string. The palindrome of a string means what? That is called as, if the palindrome of the string is denoted by the, that is called as the W power R. Sorry, the actually we have the reverse of a string is there, that is denoted by the W power R. Okay, the reverse of a string equal to the given string, original string, then such kind of strings are called as the palindrome of strings. That's why W power R, that is called as the reverse of a string. W equals to given string. If both are equivalent, that is called as both are equivalent, that is called as palindrome of a string. What are the example strings? For example, madam, Siri, Siliri, ABA, BAB. BAB. Okay, all these belongs to, that is called as the palindrome of a string. And the next one is here transpose. Transpose means this just like that is called as the reverse. Just by instead of using that R value, that just simply we can use the reverse of a string, means that is transpose of a strings. The main thing is here we have the power of an alphabet. That means here the alphabet is there, but what is meant by power of an alphabet? The power of an alphabet is called as the, that means the power represents length of an alphabet. Length of an alphabet. Okay, length of an alphabet, that is sigma. That means here the power represents what? That is called length. That's why sigma power k means what? K number of alphabets we are using. That is set of all strings of length k. Sigma equals to 0 comma 1. Sigma power 0 means epsilon. Sigma power 1 is 0 comma 1. Sigma power 2 is, that means here if you take the sigma power 0 means 0 epsilon symbols. Okay, sigma equal to 0, sigma power 1 means what? That is called a number of characters. That means number of string length is 0 and 1. And sigma power 2 means what? Sigma power 1 into sigma power 1. That means here 0 0 0 1 1 0 1 1. This means all these concepts related to the sigma power 2. And the next one is sigma star denotes what? The set of that a set of strings over the sigma of the length 0 or more. That means sigma star is called as the 0 or more occurrences. 0 or more occurrences. How to represent it? Star represents 0 or more occurrences. Okay, sigma power 0 is valid, sigma power 1 is valid, sigma power 2 until n number of sigmas. That's why suppose if sigma equal to 0, then sigma power 0 equals to what? Okay, sorry, sigma star equals to what? That is called as the epsilon 0, 2 zeros, 3 zeros, 4 zeros, any number of zeros. These all are called as the, that is sigma power star. The sigma power star, that is also called as the clean closure of an alphabet. Clean closure, KLENE, clean closure of an alphabet. And the next one is called here sigma power plus. So what is in the sigma power plus? That is called as the positive closure of an alphabet. Positive closure of an alphabet. The positive closure of an alphabet means what? Sigma power plus. Okay, that what is the meaning here? At least one character is required. At least one alphabet is required. That means sigma power 1 union sigma power 2 union up to sigma power n. So what is the difference between sigma star and sigma power plus? Sigma star is, that is called including epsilon symbols also. But if it comes to the sigma star, sigma plus positive closure, okay, that is at least one character is required. That means except epsilon, all the characters and all the strings from the sigma star. Okay. Next, once if you understand all these concepts, then these all are called as these notations of the strings and how to what are the operations on the strings. And next one is what is the alphabets and what is the power of an alphabet. Okay, now the language. The language means what? The set of all the strings. 1 minute, please. Now the language. For example, first one is basic alphabet. Afterwards, the combination of alphabets are called as the string. Now the collection of strings are called as the collection of strings over an alphabet sigma equals to, that is called as the language. That's why a language is a set of strings over some fixed alphabet. Fixed alphabet means that the given alphabet and they are denoted by the L, capital that is denoted by the capital L. The language is a collection of strings over an alphabet is called as string. That is called as the language and it is denoted by the capital L. It is denoted by the capital L. Suppose again here we have the two kinds of languages are there. The mainly the language is classified as two types, that is called as the finite language and infinite language. Finite language and infinite language. So what is by finite language and what is by infinite language? The finite language is called as, if you take any language, it contains, if you take any language, if it is contains the finite number of strings are there, that is called as the finite language. But if you take any language, if the language contains infinite number of strings are there, so that is called as the infinite language. That's why what is the example for the finite language and infinite language? Suppose any combination of zeros and ones. Okay, the string length is contains the string length is not more than 3 characters, not more than 3. The string length is not more than 3. That means how many possible values are there over and 0, 1? epsilon is there, 0 is there, and 1 is there. Afterwards, again 0 0 0 1 1 0 1 1. Next one is not more than 3. Not more than 3 means what? It is called below 3 only. That's with 3. That means that these strings are called as epsilon, 0 and 1, 0 0 1 0 1 1. These all are called as the limited strings. The limited strings are called as the limited number of limited language. Next, but if it comes to the infinite language means what? Any number of zeros are valid. Any number means what? Any limit is there? No. If there is no specific limit, such kind of strings are called as the, okay, that is called as the infinite language. That's why, but mainly here we will discuss about the, okay, here the example string, the example is set of all strings over sigma equal to 0 comma 1 with equal number of zeros followed by the equal number of ones. That means here this is also belongs to the infinite language. Okay, set of all strings over 0 comma 1 with equal number of zeros followed by equal number of ones. That means 0 1 double 0 double 1 1 0 0 1. That means here we have the all the combinations of zeros and ones are there. But next, in the language also we have the different kinds of operations are there. That is called as the union operations, concatenation. Next one is concatenation, insertion, deletion, complementation is there. Okay, union operation, intersection, differences, complementation, concatenation. Okay, no problem. Next one is a clean closure. Clean closure means what? Clean closure of a language means what? Clean closure means what? 0 or more. That's why L star equals to what? L power 0 union L power 1 union L power 2 until L power n. Next one is positive closure means what? At least 1. That's why L power 1 union L power 2 until L power n. Okay, all these carried out, all these notations are there. Next. Now, today I am going to discuss about the finite automata concept. Once if you understand it, then I am going to start the finite automata concept. Because of what are the basics of the languages, what is in by alphabet, what the operations in alphabet. That means we have power of an alphabet concept is there. Positive closure and clean closure is there. Positive closure and clean closure is there. Sigma power plus and sigma power star. Then afterwards we have the what about the string, what are the operations on strings, afterwards languages, and what are the types of languages, and what are the operations on languages. So these are the basic concepts related to the languages, and please note down it. Just I am giving the bits related to this basic concept. So what is the, if the string length is n, if the string length is n, how many number of, if the string length is n, how many number of prefixes and suffixes are available? How many number of prefixes and suffixes are available? That is called as n plus 1. N plus 1 strings are suffixes or prefixes of the given string. Next one is, again we have one more point is there, proper prefixes and proper suffixes. Proper means what? Proper prefixes means same as prefix set, but except the given string. Except the given string. That is called as the proper prefix. Next one is proper suffix also. Except the given string, remaining all suffixes are belongs to the proper suffixes. That's why here the prefixes and suffixes are okay. If the string length is n, how many number of prefixes and suffixes are there? That is called as only n strings are there. But if it comes to the general format, that is called as the n plus 1. But if it comes to the okay n proper prefixes and proper suffixes means that is called as the n only, because of we are eliminating the given string. Okay, afterwards language is there, types of language, finite language and infinite language. So what are the examples for the finite language and what are the examples for the infinite language? Now here, once if you understand the language basics, once if you know the how to collect the how to communicate with the other model, then we can start the designing of the model. So what are the different kinds of models are there here? That is, we have the finite automata is there, that is a model. And if can you give any example related to the finite automata? Actually, the finite automata is belongs to the how many number of tuples are there? We have the 5 tuples are there. So what are the 5 tuples? Q, sigma, Q naught, delta, and F. What are the 5 tuples are there? Q, sigma, Q naught, delta, and F. Now, the finite automata description is the finite automata are a mathematical model of a system with discrete input and outputs. The system can be any of the finite number of final states, internal states, and set of transitions from one state to another state. And applying input on the input, the machine moves from the one state to another state in reverse side also. That's why here the finite automata is described by using of 5 tuples Q, where Q is a finite and non-empty set of states. Next one is here the sigma equals to 0, 1. Next one is sigma equals to, and next one is delta, and next one is Q naught, initial state, and next one is called as the final state. Okay, here the definition for the finite automata is Q, sigma, Q naught, delta, and F, where Q is called as finite and non-empty set of states, and where sigma equals to what? That is finite and non-empty set of input symbols. And transition function means what? How the system is moving from the set of input symbols. And transition function means what? How we are moving from the one state to another state. So that is called as the transition function. Okay, and now here the overall the and again we have the Q naught is there, initial state and the final state is there. Q naught is called as initial state and F is called as final state. That means for every mission we have exactly one initial state is there. How many initial states are there? Exactly one initial state is there. And how many final states will be there? That is called as depends upon your situation, depends upon the language. We can use the more than one state as a final state. More than one state as the final state. Okay, that's why overall the definition for finite automata is finite automata can be represented by the 5 tuple notation, where Q is a finite and non-empty set of states, and sigma is a finite and non-empty set of alphabets. Delta is a transition function or mapping function. And next one is the transition function is described from word that is called as the q into sigma gives q. That means q means what? Any one of the state from capital Q. And sigma is called as what? Any one of the input symbol from the sigma. By using of these two characters, we can switch to the other state that is also from the capital Q. Okay. Now initial state is called as Q naught is initial state, and F is called as set of final states. Okay. Now, how to represent it? The any diagram, any finite automata can be represented in two ways. One way is belongs to the transition table or transition diagram. One way is belongs to the transition diagram, or we can use as transition table. That's why the transition diagram is called as a state diagram, state graph, that is also called as the transition graph or a state graph. That means if you take the any graph means what are the components are there for graph? That means we have the we have the that is called a set of edges and set of nodes are there. The nodes means what? That is called as the vertices, and edges are called as the that is called as the how we are moving from the one place to another place. The path is called as the edges. That's why in that way also we can consider as the transition diagram. So how to represent the edges and how to represent the nodes? That is called as all the states. States are assigned for the nodes. That means that is represented by the single circle. That is represented by the small circle. The nodes means what? One path to another path, one node to another node. How it is moving from one node to another node. So that is called as the path. Okay, a state diagram is a directed graph with a nodes and edges in which each node corresponding to the one state of the system and edges are corresponding to the transitions of the state, and each node is labeled by the state name and edge is labeled as the input symbols. That's why all the states are represented in the form of the small circles. And again in that states also we have different states are there. Different states are there, that is called as the initial state. Initial state is there. The initial state is prefixed with the arrow mark. This is called as the initial state, and starting state of the system is called as like this. That means how many initial states are there in that model? We have exactly only one initial state is there. Next one is the final state means what? How to represent the final state? The final state is called as that is the represented by the double circle. Within double circle, if you write the state, that is called as the final state. Then afterwards, both final state and initial state is represented by the third character. This like this. Okay, and what are the how to represent the states here? The states are represented by the small circle, and we have the different kinds of states are there. Initial state and final state is there, and normal state is also there. Okay, and transition table. Table means what? That contains the here set of rows and columns are there. Set of rows and columns are there. The rows are belongs to the state names, and columns are belongs to the input symbols. That's why the transition diagram can also be presented in the transition table. By each row represent the state, and whereas each column represented as the input symbols. Okay, that is called as initial state and starting state, that is represented by the arrow mark, and final state is represented by that is called as the double circle. Okay, afterwards you can give the transitions. Now I am giving the example related to the transition model. So what is the finite automata model? So what are the components are there? Because of now I am going to construct a designing, and before once the theoretical concepts are there, I am using the board also. Don't worry. Okay, these all are the today we are discussing about theoretical concept. That's why I'm using this document. Now here the model and a finite automata structure. Okay, what is the model contains? That means we have the three modules are there. That means three components are there. So that is called as three components are there. What are the three components here? Finite control system and input tape is there. Finite finite control system. This is called as the finite control, which contains the number of states and all transitions about the system is maintained by the finite control system. And the next one is called as input buffer and input tape. Next one is called as the input tape or input buffer. And every string ends with the dollar sign. That's why here the strings are ends with the dollar sign is there. And next one is here we have the input read head is there. With the help of the read head, we can read the symbols from the input buffer. Then afterwards here we have the some states are there. Okay, what is the concept here? The first one is always the read head points to the start symbol of the starting character from the input buffer, and afterwards for after reading the first character, okay, the forward control will be moved to the next state. Then afterwards again we are identifying the on the symbol will be in the same state or will go for the next state. That means likewise we are consuming the entire string. By the end of the string, the current state is belongs to the final state. We can consider as the given string is called as the accepted by the Finite Automata. Okay, the given string is called as accepted by the Finite Automata. Allow you once again, please listen. How the system is identified as the given string is valid or invalid. By the end of the string, if you are able to reach to the final state, so that is called as the accepted by the. That accepted means what? That is called as the. Let me the particular string is valid in my language. The particular string is valid in my compiler. So that is considered the acceptance of the language. Okay. And now by the end of the string, the current state is belongs to final state. The particular string is called as accepted by the Finite Automata. Okay, this is the model. Generally, we have the finite automata. We have two models are there. Two finite automatas are there. That means two types are there. So what are the two types of finite automatas? That is called as NFA and DFA. That is NFA and DFA. NFA and DFA. So what is meant by NFA and what is meant by DFA? What is meant by NFA and what is meant by DFA? The NFA stands for non-deterministic finite automata. Non-deterministic finite automata. Non-deterministic finite automata. The non-deterministic finite automata means what? That means here sometimes we have the more than one path on some specific input symbols, or sometimes no path on some specific input symbol. Such kind of notation is called as the, okay, that means non-deterministic. Non-deterministic means what? It leads some confusion. When we get confusion, if there is no path, or for example more than one path is there, for reach to the same destination, then you'll get the confusion. So okay, such kind of transitions are there in any mission. That is called as the non-deterministic format. That is called as non-deterministic finite automata. And next one is the DFA means what? We don't have such kind of notations. That means on every input symbol, the path is required from every state. Okay, here that is called as the DFA means what? Deterministic. That means without having any confusion. Okay, without having any confusions, we can reach to the final state by reading the string. Such that is called as the deterministic finite automata. But what are the rules for deterministic finite automata? That is called as the deterministic finite automata. That is called as from every state on every input symbol, path is required. Then only it is considered the. Then only it is called as the deterministic finite automata. Okay. Now in the next class I am going to explain about how to design the DFA and how to design the NFA. Okay, till now if you have any doubts you can ask me now. If you have any doubts, you can ask me now. Yes. Okay, any doubts? Okay, no. Okay, in the NFA and DFA, what is the difference is? Okay, in NFA, we don't need to, no need to follow the any rules. Directly we can use the some symbols, or otherwise more than one symbol also we can use from any state. That means there is no there is no restrictions about the transitions. But if it comes to the DFA, we have some restrictions are there. What kind of restrictions are there? That is called as the, on every input symbol there is a path from every each and every state. Exactly how many number of times? Only one time. Okay, that is considered the DFA format. But if it comes to the NFA, no need to follow like this, but only the string is accepted, that's enough. Okay. మేడం, మాకు మీటింగ్ అని పెట్టారు మేడం, ఇప్పుడు 3:15కి మెసేజ్ పెట్టారు. మీటింగ్ అని చెప్పి మెసేజ్ పెట్టారు మేడం మాకు. కొద్దిగా పర్వాలేదు మేడం, మరి వీళ్ళు ఒక హాఫ్ అన్ అవర్ తీసుకుంటారా మీటింగ్ ఇప్పుడు, లేదా తర్వాత కంటిన్యూ చేయమంటారా ఎట్లా మేడం? మళ్ళీ వీళ్ళు వస్తారా లేదా అని. రేపు పెట్టమంటారు మేడం, రేపు క్లాస్? ఓకే మేడం. ఓకే ఓకే మేడం, థ్యాంక్ యూ. ఎస్ ఎస్, తులసి ఇస్ దేర్. తులసి, తులసి. మై okay, tomorrow also we have the class, but what time you are available for tomorrow?
10 to 1 వరకు ప్రోగ్రామింగ్ క్లాస్ ఉంది సార్.
10 to 1 వరకు. ఆఫ్టర్నూన్ అమ్మా?
ఇంకేం చెప్పలేదు సార్.
మరి రేపు ఆఫ్టర్నూన్ తీసుకుని, నాకు ఇప్పుడు మీటింగ్ ఉంది ఒకటి, అందువల్ల నేను కొద్దిగా ఇప్పుడు స్టాప్ చేస్తాను. రేపు ఏ టైం పెట్టుకుందాం అంటారు రేపు క్లాస్? రేపు ఏ టైంకి అమ్మా?
ఏ టైం అయినా పర్లేదు
సరే అమ్మా, అయితే ఆఫ్టర్ 1 o'clock పెట్టినా మరి క్లాసు, లేకపోతే టుడే లాగే సేమ్ 2 to 4 పెట్టినా? అదేనమ్మా, ఒకసారి మీరు అందరూ డిస్కస్ చేసుకుని ఒకసారి మేడంకి ఇంటిమేట్ చేయండి, లక్ష్మి మేడంకి.
సరే సార్.
ఓకేనమ్మా, ఓకే, థ్యాంక్ యూ. రేపు నేను బోర్డు ఇచ్చేస్తాను, బోర్డు ఇచ్చే చెప్తాను. ఓకేనమ్మా, థియరీ కాదు, బోర్డు ఇచ్చే చెప్తాను. ఓకే, థ్యాంక్ యూ.